Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at IPv4 address structure. We'll be discussing network and host portions, the subnet mask, the prefix length, network address, host address, and broadcast addresses. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. An IPv4 address is 32 bits long. That's a string of 32 ones and zeros. That identifies the computer on our network. Now, as we look at this IPv4 address, there's two parts to this. The first part is the network portion. That identifies the grouping of computers. This grouping, it could be in a room, could be a floor in a building, it could be the entire building, but it's some grouping of computers. Then the second part here is the host portion. When we look at the host portion, it identifies the individual device on that network. And so these two work together to get us our IPv4 address. To identify the network portion and the host portion, we use a subnet mask. We compare it bit by bit, going from the left to the right side, and we look at these bits and we identify what portions they are. Now, the actual process is called ANDing, A-N-D-I-N-G, ANDing. And it's a logical process of how we go through and find our network portion versus our host portion. When we're talking these IPv4 addresses, usually we talk about a subnet, but a lot of times when people talk about these IPv4 addresses, they talk about a slash number or a prefix length. And sometimes it's a little bit easier to understand. If we look at a subnet mask is always followed by a subnet mask always has all ones at the beginning, at the left side of it. At the end of it, it always has zeros. Now, the number and the amount of ones and zeros could be different. And it will be different depending upon your scenario and what you're doing with them. But it's always ones on the left side, always zeros on the right side. The subnet mask identifies where that change happens between the network portion and the host portion. Now, this prefix length, or this slash number, what this is basically a shorthand for writing our subnet mask. If we notice 255.0.0.0, that's equal to 8 ones. 8 ones, 8 bits here, and they're all ones, that's equal to 255. Then we have 8 zeros, that gives us a 0 here. Then we have the third octet has all zeros. And the fourth octet, that has all zeros. We have 8 ones in the network portion and 24 zeros in the host portion. What we do is when we represent this prefix length, there's like I said, a lot of people call it a slash number, is we write a slash and then the number of bits in the network portion. So number of bits in the network portion. And a lot of times people use the subnet mask, 255.0.0.0, interchangeably with the prefix length, that slash number, /8. And so during a conversation, you may hear somebody say 255.0.0.0, and you may also hear them say a /8. And as you can see, as we work through these examples here we have 3 255s. That's three groups of 8 ones right here. That's 24 ones there. That's our slash number. We have 24 ones here, and we add another one into that. That gives us a /25. And we can see how that number works all the way through. To determine the network portion of an IPv4 address, we use this AND. It's a logical AND. And what that is, it's a comparison. It compares two things. If both things are true, the answer is true. Or in terms of computers and binary numbers, if both of them are a 1, then the answer is a 1. But if either one of those two that we're doing the comparison on is a 0 or false, the answer is false. Okay, here's our example. As we look right here, we have a 1 from our subnet mask. What we did here is we have an IP address of 192.168.10.10. We took the dotted decimal notation, we changed it into binary. Anytime you're going to do subnetting, you need to make sure you change that into binary. We have a 1 right here for our IP address. Then we take our subnet mask, we write it down below it, and once again we turn that into a binary. A lot of times this is fairly easy, because if you have the number 255, that means that we have 8 ones here. And so what we do is we compare the columns. We take the first number from the IPv4 address, we take the first number from the subnet mask, we compare them, we AND them together. We have a 1 and a 1. Anytime you have a 1 and a 1, that equals a 1. And that's what we have here. Then we look at the second column. Second column, we have a 1 and a 1 here. That gives us another 1. Third column, we have a 0 and we have a 1. 0 and 1. Anytime there's a 0, the answer is a 0. And as we work through this, you're going to notice that the numbers, we have another 0, 1. We have another 0 and 1. Gives us a 0. 0 and 1. Comes down to here. And finally the last one, a 0 and 1. That gives us a 0 here. Once we have the result of our ANDing process, we can then take these 8 bits, convert it into binary. This is the 128 field or column. This is the 64 column. 128 plus 64, that gives us 192. And we can finish this process all the way down through the second octet. It comes out to be a 168, mainly because there's all ones here. The third octet comes out to be a 10 here. That's what we started with, because we have ones here. But then between the third octet and the fourth octet, this is where we see the subnet change between the network portion and the host portion. We go from ones to zeros. And now anytime you AND anything in this fourth octet where we have zeros from the subnet mask, because we have zeros here, anytime you AND anything with a 0, the answer is 0. And that puts this all at zeros here. Convert it into decimal. And then this here is our network address. We started with the IPv4 address. We got the subnet mask and we ANDed those two together, and that gave us our IPv4 network address. I hope you're liking this episode on IPv4 address structure. If you have the time, please leave a comment and let me know what you think about the IPv4 address structure. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. All devices on an IPv4 network need a 32-bit logical address in order to communicate. This 32-bit IPv4 logical address consists of a network portion or network ID on the left and the host portion or host ID on the right. The length of these depends upon the size of the network. Larger networks will have a longer host portion. A network can be thought of as a range of addresses. All devices on the same network have the same bit pattern for their network ID, for their network address. But their host portion will be different. That bit pattern in the host portion will be different. Some addresses in this range are reserved and have a special name and meaning. For example, the first address in this range is used to identify the network itself and cannot be assigned to any host. It is referred to as the network address. The last of the addresses is called the broadcast address and is used to send a message to all devices on the network at once. It also cannot be assigned to any host. All the addresses between the network address and the broadcast address make up the usable or valid host addresses and can be used to address the host on the network. Let's take a look at how these addresses are determined. In order to forward data, a device needs to know what network it is on. Using their host IP address, their subnet mask, and a process called binary ANDing, a device can find what is referred to as the network address. This address represents the network to which it belongs and will be slightly different than its host IP. To do this, the host compares the host IP and its subnet mask bit for bit. If the bit values are both a binary 1, the result is a binary 1. If one or both of the bit values is 0, the result is a binary 0. Let's take a look at an example. Let's say we have a host with an IPv4 address and subnet mask of 192.168.2.38/24. And then we're going to use ANDing to find the network address of the host. Here's the host IP in binary. Here's the subnet mask in binary. If we compare them bit for bit, we can see that a 1 and a 1 right here in the first column, that is equal to a binary 1. In the second column, a 1 and a 1, that results in a 1 also. A 0 and a 1, that results in a 0. And in the fourth column, a 0 and a 1, again, that results in a 0. And so on until we have compared all 32 bits. Notice that the last octet here is all binary zeros in our network address. Because we are using a /24 subnet mask that puts our line in our 32 bit here, the first 3 octets here represent the network portion. That's these 3 octets right in here. And the last octet right here, that represents the host portion. Network addresses will always have zeros in their entire host portion, however long it is. In this case, the last 8 bits. If we converted to dotted decimal, we can see that this host belongs to 192.168.2.0/24 network. That is its network address. Now let's determine the broadcast address for this network, which is used to send a message to all devices on the network at once. Where the network address had all binary zeros in the host portion, the broadcast address will have all binary 1s. Since the host portion in this example is just the last octet, to determine the broadcast address, we keep the network portion the same and change the host portion to all binary 1s. This results in a broadcast address of 192.168.2.255. Next, we'll determine the usable host addresses, which lie between the network address and the broadcast address. The first usable host will be all binary zeros with a binary 1 at the end of the host portion. Converting to dotted decimal, this tells us that the first usable host address on this network is 192.168.2.1. Lastly, we'll determine the last usable host, which will be all binary 1s with a 0 at the end. The opposite bit pattern of the first usable host. Converting to dotted decimal, we get 192.168.2.254. Let's recap our calculations. We began with a host address of 192.168.2.38/24. Using binary ANDing, we determine that this host belongs to the 192.168.2.0 network. Keeping the network portion the same, but placing all binary ones in the host portion, determine that the broadcast address for this network is 192.168.2.255. Again, keeping the network portion the same, but changing the host portion, we determine that the usable host range for assigning IP addresses to devices on this network, which is 192.168.2.1, which is one more than the network address, and 192.168.2.254, which is one number down from the broadcast address. You can see that our original host IP address falls within this range. Things to keep in mind when working with IPv4 addresses. All IPv4 addresses are 32 bits in length. A portion of the address represents the network that the host belongs to. This starts at the left. The remaining part is the host portion, which identifies the host on that network. And there are two special reserved addresses on every network that can't be assigned to hosts. One is the network address, which is the lowest or the first address in the range of addresses that represents the network that all devices belong to. And the other is the broadcast address, which is the highest or last address in the range and can be used as a shout out to all devices on the network at once. Thankfully, there are shortcuts you can take to calculate these addresses without having to convert to binary first. But examining these addresses at the bit level should help you understand how networking devices interpret them, and also how the dotted decimal format is derived. Let's take a look one more time at our network, host, and broadcast addresses. Here in this example, we have a subnet mask of a /24. That /24 in dotted decimal notation is 255.255.255.0. If we write that out in binary, we have 24 ones followed by 8 zeros. That signifies the difference between our network and our host portion right here. Our network address is the first 3 octets. That's our first 3 octets right here. And then in the host portion, we have all zeros. So our network address is 192.168.10.0. After you find your network address, I would go and I would find the broadcast address. If we look down here at our broadcast address has the same network portion. Now, this network portion is given to you by your internet service provider. It's given to you by your network administrator and said, here, use this. You can't change anything here, so it's going to be the same all the time. But then the host portion for a broadcast address is all ones. That's what we have here, is all ones at this point. That gives us our broadcast. That allows us to send the message to all devices on our network at the same time. And then once we have our network address and our broadcast address, what we can do is we can find our range of usable addresses. Our range goes from the lowest usable address to the highest usable address. To find the first address, that lowest IP address you can assign to the device, you take your network address, and the host portion right here is a 0, and you just add 1 to it, which, like the chart shows us, is all zeros with a 1 at the end. Then to find the last address, what I like to do is I take the broadcast address and I subtract 1 from it. Doing it the binary way, that would be all ones with a 0 at the end. And that gives us our addresses. And now, if we look at the diagram down here on the bottom, this is our network address. Right here is our network address, 192.168.10.0. Every address in our network, in this yellow circle, starts with the first 3 octets of 192.168.10. That is our network address. And then the 4th octet. Every device on that network has a unique 4th octet. It identifies that device on the 192.168.10.0 network. It was my pleasure to bring you this wonderful episode on IPv4 address structure. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks for the CCNA. In the bottom right is one of my favorite videos that I picked just for you. Thank you so much for watching this episode of my series on Introduction to Networks for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.